Let's take a look at an example. We want to find the expected return, the expected variance, and the expected standard deviation of a stock had the following returns and probabilities for each outcome. So look, the outcomes are bad, medium, and good. Those are the three things that could happen. If things are bad, the return would be negative 40%, which is pretty bad. Likelihood of that happening is 20%. Things are medium, returns 10%. Real good chance of that happening, 60% chance. And if things are good, 50% return, which is fantastic, and there's a 20% chance of that happening. And again, notice how it happened. In this case, it happens to be symmetric. That doesn't have to be the case. The one thing we do want to make sure is that the probability is at up to 100%. So we don't know what's going to happen, but we do know that what does happen is either going to be bad, medium, or good. There's a 100% chance of one of those three happening. So the first thing I like to do, or we can do, is make a table. Lay out your outcomes. You got bad, medium, and good. Lay out the returns in each of those outcomes. And lay out the probability, which is the weight for the expected return. And remember, the expected return is just the weight times the return, the sum of the weight times the return for each of the possible outcomes. So a table can help us do that, where 20% chance of a return of negative 40, so 0.2 times negative 0.4, plus a 60% chance of return of 10% because things turn out medium, 0.6 times 0.1 is 0.06, and a 20% chance that things will turn out good and have a return of 50, 0.1, add them all up, and the expected return across all the states, given what could happen in each state and the probability, is an expected return of 8%. So the next step we want to do is find the deviation. So if things turn out bad, the return would be negative 40. The expectation across all possibilities is 8%, and so negative 40 is 48 percentage points below what we expected. So we got negative 40 minus the 8 that we expected, and that's how we get the negative 0.48. If things turn out medium, we're at 10%. We expected 8, so expected 8 across all possibilities. So at 10%, if things turn out medium, you're actually 2 percentage points over. And finally, if things turn out good, then you're at 50 percentage points, a return of 0.50. The expectation across all possibilities is 8%, and you would be 42 percentage points over, 0.42. Next step is to square the deviations. Negative 0.48 squared, 0.2304, 0.02, 0.004. Notice you get a really small deviation squared because you had a small deviation, because if things turn out as medium, it's at 10, the expected was 8, and so you're close, and so the deviation is small. If you're at good, you're at 50, which is substantially higher than what we expect. Square it, and you get another big deviation. What are our weights for these deviations squared? They're simply the probabilities of those things happening. You don't make any adjustments, 0.2, 0.6, and 0.2. Multiply the weight times the squared deviation, and then you add them up, and you get the variance. So the variance in this case is 0.08160. Standard deviation is just the square root of that, 28.6%. So it can be done in a rather methodical way. If you're more comfortable with the formulas, find the expected return, 20% chance of negative 0.4 plus 60% chance of 10% plus 20% chance of 50 gets you to 8.0%. So what is the expected variance? 20% likelihood of outcome 1. There's your deviation squared. 60% chance deviation squared. 20% chance deviation squared. And you get 0.08160. Take the square root, 28.6%.